what is quantum computing and how is it going to change how the world works?
Okay, so quantum computing is a new type of computing where we actually use the quantum mechanical properties of particles to do the computation. So this was an idea that emerged in the early 80s, and at the time it was really sort of a philosophical idea that was hypothesized because there are certain hard tasks that normal computers struggle with, and one of them is like simulating physical systems. And so Richard Feynman and others proposed that maybe we try and build a computer out of like quantum mechanical systems, and maybe they could do that task easier, and maybe that would be a new type of computing. And then 10 years later, there was a huge breakthrough, and Peter Shor discovered that this device, or these sort of processes that might be designed to simulate quantum systems, were able to break crypto systems, which was like a radically new idea. And from then, like, it shot a rocket under the field, and then people began really thinking hard about how do you build these things. And fast forward to today, we've got people, we're beginning to get quantum processors that are at the point where they can begin to outperform classical computers for certain carefully chosen tasks. And that's a huge breakthrough. It's really showing that there is a new type of computing, and it's different from the type of computing that we had before.
So that sounds exciting in the abstract, but what would be some concrete examples that people could really appreciate?
Right, that's a great question. So the really important application from my point of view, like everyone has a different point of view about this, but for me, it's all about finding new ways of doing chemistry, material science, and things that involve simulation of like complex systems. So quantum computers are much better than classical computers at simulating certain very difficult to simulate physical systems. Now, again, that sounds pretty abstract, but it's at the core of many of our technologies and things that we do. So, drug design and development, which is of course a huge industry, but also like energy transport, like development of batteries, all of these sort of things involve doing heavy computations on complex physical systems, complex quantum mechanical systems. That's what quantum computers are designed to do well.
And so will quantum computing make those tasks faster, or will it make them qualitatively better, more insightful, deeper?
A bit of both. So one of the things that's really important to know about quantum computing is it's not just a question of faster and bigger memory and things like that. It's actually a different computing model. So the way in which the logic works when it does the computation is subtly different to the way that supercomputers do it now. But that subtle difference turns out to be dramatically important for certain key tasks. So problems that were basically impossible to solve on a really big computer system can become possible to solve. But not every problem has that property. So one of the really tricky things that we have to do, and the thing that I actually research, is which types of applications and which types of problems can quantum computers actually deliver an advantage on.
Terrific. Okay, so what are you excited about in the world of quantum computing today?
Wow, I'm excited about many things. So the first thing I'm really excited about is that the hardware development has dramatically improved in the last few years. And it's really, we're seeing really rapid progress now in that development. Part of that is due to, we sort of reached a tipping point in the technology, and a lot more money has come into the field. The level of engineering has gone up. This has also allowed people to begin to explore the scientific progress of this in new ways. So that's the first thing I'm really excited about. We're just now reaching a point, as I said earlier, where quantum processors can begin to outperform classical computers for certain specific tasks. Now, the other thing I'm really excited about is because of all this improvement in the hardware, we're seeing people come over to look at the software applications for quantum computing, and we're seeing people come from chemistry, material science, all over, to begin to think about how they can use this new tool, which quantum computing is, to solve the problems that they care about. And so now you go to a conference, and like when it used to be computer science mathematicians and physicists talking to each other, we now have chemists and material science and people from all over the sciences to come and talk about how to develop new applications and to turn these things into products.
Yeah, a much more cross-disciplinary approach and view. Terrific.
The average attendee at CeBIT should begin to think about how quantum computing is going to impact their business. So businesses around the world, and big businesses around the world, are beginning to think about how quantum computing might give them an advantage in technologies that they're developing, or how it might give them an advantage in processing the data that they acquire. That sort of thing is the thing which a lot of people are looking at. The other very important aspect of this is that quantum computers are very good at attacking certain crypto systems. And thinking about how you should transition your security arrangements to deal with that is a thing that businesses should start thinking about. It's a good starting point for getting into quantum computing, is worrying about this security issue, which is real. It'll be a very big issue probably in 10 years' time. They should begin to think about how they're going to deal with that. And go talk to your local quantum computing research team at your university and ask them, what are the problems we should be worried about in this regard, and that will give you an entry point into thinking about how to develop applications and the science underlying all of this.
Okay, terrific.